Okay, good morning, everybody, and welcome to British Potato 2023 and the first seminar slot. My name's Dr. Rosie Bryson. I'm the Head of Marketing and Communications for CHAP. Some of you may or may not know who CHAP is. CHAP is Crop Health and Protection, and we're one of the agri-Tech centres. If you're particularly interested, we have a stand here, stand 139, and we've got a couple of leaflets on the chairs that you might want to have a look at as well. I'm just going to chair the session for today. Just for information, there is no planned fire drill, so if you hear a noise that sounds like a fire alarm, it's probably best to get out. Anyway, the objective of the seminar this morning really was just to talk about agri-Tech ecosystem and really how innovation is actually being applied to potato production in the UK. We have several case studies that we're going to talk about, and some of these are actually covered on the leaflets that you have. For information a little bit later, one of my colleagues, Alex McCormack, will mention a webinar that we have coming up soon as well. If anybody's interested, there's a QR code which you might want to connect to. Our first speaker is Andy Evans, and probably needs no introduction at all. Andy is our innovation sector team lead within CHAP, and he's going to talk about the agri-Tech ecosystem and in relation to how CHAP actually works and how it helps leverage funding from Innovate UK particularly, but also talk about crop storage and post-harvest solutions. So, Andy, over to you. Thank you.
Right, good morning. So it's a pleasure to be here. Do we go back one? Yeah. So I'm Andy Evans. I've worked on potatoes for quite a few years. Just been at CHAP now about 18 months, and really just want to talk about what CHAP actually does, particularly in terms for growers and for academics, and also from an industry perspective. And our purpose, really, when we were set up back about 5 or 6 years ago, was to really help bring innovation to the crop health sector. And that involves working with growers, working with industry and academics, bringing them together and really facilitating the funding. And there's a video here which will hopefully explain it all, so I don't have to.
Innovation is a cycle. It grows over time, with each iteration building upon the next. We're Crop Health and Protection, or CHAP for short. Funded by Innovate UK, we promote collaboration between the UK government, researchers and industry in the field of agri-Tech. At CHAP, the innovation cycle underpins the process we follow when guiding and mentoring collaborators through projects. Every project starts with an idea. It can take many years and multiple stages for an idea to become a project suitable for funding. We bring people together and guide them through this process to give them the best chance of success. To develop a proposal, we examine the various funding sources available and identify the content needed for the bid. We help to determine the processes and facilities required, and the project story that will deliver most impact. Once a project has the green light, there are further challenges to overcome. CHAP's project accounting and project management teams provide support from handover to closeout to ensure the project stays on budget, in scope, and is delivered on time. CHAP projects are at the cutting edge of innovation and R&D, and ideal for sharing with a wider audience. We communicate updates about projects at their launch, midpoint, and upon completion to spark interest in our sector. Part of this is evaluating the impact the project has on the environment, economy, and society, while also assessing improvements for future work. As one spin of the innovation cycle completes, others are just beginning, or are in mid-flow. CHAP is here to guide all, from startups to multinational companies, on their journey through the innovation cycle, building networks in agri-Tech to turn ideas into projects with real-world impact.
Said much better than I probably could. So really, one of the things that we have within CHAP is a network. You can become a member of CHAP, and that allows you access then to a network from SMEs, academics, multinationals. And as Rosie's mentioned, we've got a webinar coming up where one of our companies is actually, companies we work with is talking about a project that we've worked in with them. So it's a way of basically networking, being able to help develop projects from very initial concepts all the way through. And if you look at the map behind me, we partner with several organizations throughout the UK where we've got what we call our capabilities. So I'll be talking about the crop storage ones in a minute, but we've also got vertical farms, glass houses, molecular diagnostics, digital phenotyping, a whole range of capabilities under the sort of CHAP umbrella, which are hosted at academic organizations throughout the UK. A couple of projects which my colleague Alex will be talking a bit more detail about shortly, but I'm just going to flag them up just now. One is about DCYST, which is for a trap crop for PCN, potato cyst nematode. And another one is Potato Light, which is a large project which has got the likes of McCain's, PepsiCo and so on involved, which again Alex will fill you in on. But really I want to talk today about crop storage, and you're probably all aware that Sutton Bridge was the kind of prime crop storage research facility in the UK for many years, but obviously with HGB and potatoes coming off the landscape, Sutton Bridge basically closed down. And that basically left a gap from the UK perspective in terms of research and capabilities to look at crop storage, including potatoes. So within CHAP, we have what we call a new innovations program. And so within that, we identify a problem. And what we really identified is that there are challenges to crop storage going forward into the future, and there were no research facilities available to try and address those challenges. So we talked about internally initially about an integrated solution to try and address those challenges. And we have what we call our kind of 6-step pathway where we engaged with stakeholders across the potato, well, not just potato industry, but also the soft fruit industry in terms of crop storage. And we held at least a couple of workshops, bandying about loads of ideas and working up, ultimately, a business case for storage for horticultural crops. And we came up with sort of 4 shortlisted options, which were workshopped, again, with stakeholders, so that ultimately we developed one business case, which we then took towards, or we took to Innovate UK, and we were able to work with partners like ADAS, SIUC, excuse me, and the NRI, University of Greenwich, to develop a crop storage solution. And that's basically what we now have. It's called Crop Storage and Post-Harvest Solutions, CSPS for short. And this is a partnership between CHAP, ADAS, NRI, James Hutton Institute, I mentioned them, and also SIUC and SSE Consulting. And this is now literally just coming on stream. The validations for these facilities have been undertaken, and we now have 3 basic kind of sites. So we have fixed location controlled temperature rooms at the James Hutton Institute and also at ADAS Boxworth. And we also have what are called P-pods, which are sort of mobile, very small containers where you can do controlled atmosphere and storage work within on potatoes and other food storage material. So the outcome of all of this is now that we do now have, again, a post-harvest research facility available for both research and also commercial work in the UK. And facilities in Scotland, which were also part funded as well. We've had, there are 6 storage rooms in GHI, 3 funded by CHAP through Innovate UK and 3 funded by Scottish Government. So what we've got with these are, excuse me, so they've got multiple chambers, so you can store, whether it's potatoes or any sort of material, you can undertake fumigation, you can look at sprout suppressants, you can control the atmosphere, temperature, humidity, and so on. And basically, you can look at a whole range of crops in there, but particularly potatoes. The pea pod, which is the bottom right, as you look at it, these are mobile experimental units that can be taken and placed in existing commercial stores, and basically you can play around with things like the humidity, temperature, and so on in those as well. So there are 5 of these pea pods, and they can be deployed basically anywhere in the country. So we've got the appropriate research facilities now. We've got expertise as well associated where these facilities are. So at the James Hutton, there's obviously the potato experts there. You've got potato experts down at ADAS, and then also down at NRI as well, to basically work utilising these facilities for the benefit of industry. The one thing we don't have is the funding, really. We know we've got the funding to set these up, but we're really looking now for you, for the industry, really, to utilise these facilities, whether it's through a research proposal, which you can work up with through CHAP, or you can use them as a commercial resource. So these are now available. If you can speak to CHAP, or you can contact the Hutton or ADAS or NRI directly. So the one thing, the big strength, I think, with all of this is that you've got the associated expertise at these research centres where the storage facilities are. So a whole range of things, from the molecular diagnostics to looking at different stresses, looking at disease, you name it. The associated expertise at these locations really add to the fact that we've got these storage facilities. So where these storage facilities fit really is, if you think of it as a sort of pipeline going from left to right, where you've got maybe some initial mechanistic research work done in like a university lab, for example, and then the next step then is the pea pod stage micro stores, where you can have an initial look to see what your research does within a sort of enclosed small chamber. Then you've got the macro stores, as we call them, the 4-ton and 6-ton stores, which are based at the Hutton and at ADAS, where you can undertake much more controlled work. You can introduce controlled atmospheres, you can change humidity, temperature, storage time, whatever. And then the next step then is the kind of macro or spot stores, which are again, on a sort of larger scale, again, maybe utilising commercial stores as a kind of experimental tool. And then obviously you've got the commercial stores where the growers will actually deploy these methods, which have hopefully been developed right through this kind of pipeline. So some sort of research areas that you may want to sort of think about, particularly from a potato perspective, you've got obviously working with say new sprout suppressants. You've got assessments of storage on varieties. If you've got new varieties coming through from the breeders, you can look at how they cope under different storage regimes. You can look at trying to design stores or look at modifying atmospheres and so on. Basically, these research options are now available to be utilised at these stores across the UK. So to summarise, we now have equipment and resources available for not just potato storage, but crop storage research. The skilled people at these locations who can actually help with the running of any sort of experimental or commercial work that you want to evaluate. One of the key things I think we should mention as well is about training, because we're all some of us are kind of getting on a bit, and we do need to have new blood who have got skills developing, looking at crop storage kind of work. So these facilities now available, and we'll be really look forward to people approaching us to try and develop crop storage work going forward. And that's me. So we'll have questions after the 3 presentations, but forward to questions later on.
Thank you. And just to summarise, we have actually a leaflet on this, and I think it's really important from the crop storage perspective, because I think with the closure of Sutton Bridge, we would have been left without any research facilities in the UK, and particularly with things like suppressants, where registration is still really important. Some of the challenges around energy use in crop storage now as well. I think these facilities are really very good. Now, Alex is also from CHAP, and he's our innovation team lead for agronomy. And I think one of the areas that the industry is facing is clearly loss of chemistry is a big challenge, and obviously the drive towards net zero and regenerative agriculture. And the topic that Alex is going to talk about, he'll introduce anyway, but is to talk about 2 really key projects which I think are fascinating to help address some of these issues, and funded via Innovate UK, but just an example of some of the projects that CHAP helps to facilitate. So over to you, Alex.
Thank you very much, Rosie. So really what I'd like to do today, a bit like Rosie says, is talk about some of the challenges that we face as a sector, some of the projects and case studies that we've developed with a lot of the stakeholders at this event today, to try and overcome and tackle these challenges. And ultimately it's about future-proofing the sector. It's about ensuring that future viability as we move into a more uncertain future compared to what we have traditionally faced. So I think there are many challenges, but for me, some of the key challenges that we face as a sector are around these issues, and these are roughly the themes and topics that I'll talk about as well. Really, one of the big things that we all are aware of is the decreasing availability of synthetic pesticides and the reduction of active ingredients on the market, which is causing a lot of gaps in our control of key pests and diseases, whether they be current endemic pests and diseases or those that might come in due to climate change or through trade. Alongside this, we're also seeing increased resistance from the decreasing toolbox that we've also got available and the historic use of these products. So we need to try and find new ways to overcome these. For example, do we use more biological or more holistic-based solutions? But these don't always work straight out of the box. The final ones really are about the big elephant in the room. So potatoes as a crop require a large amount of cultivation to get that good seed bed, that good quality and yield. So is there a way that we can pull back from that now that we're entering a period of more regenerative agriculture, of more minimum inputs and minimum tillage? And then finally, how can we take a more holistic, bigger view, redesigning our systems? Arable world is starting to do this, but for potatoes, where it's often rented land that might be outside of your control for the rest of that rotation, how do you ensure a bigger picture view when managing weeds, pest diseases, cultivations, and a whole range of inputs, really? So finally, some project case studies here just to cover. So the first one I'd like to talk about is the DCIST project. DCIST is a trademark brand name for a range of solanaceous trap crops sold by Produce Solutions. And we were able to help them in securing Innovate UK funding to further advance the development of their range and also get it more into the hands of growers. So this project was a 2-year feasibility study. We're coming to the 2nd year now, coming to the end of the project. And really this was driven by a want for better tools for growers. So the potato cyst nematode, or PCN, quite a common pest of potatoes. About 48% of the UK's land is infected to some extent with PCN. Traditionally, we have a variety of management techniques that are available, longer rotations, 1 in 6 or longer. We have resistant and tolerant varieties, but these don't always meet the certain specifications needed for certain processors and end users. And then finally, probably the most common is we have granular or synthetic nematicides. However, over the last couple of decades, we've seen the number of nematicides available dramatically drop, and the future of those that remain is somewhat uncertain. So what we really need is better tools in the toolbox. And in this project, we're using a range of plants to try and tackle this. So the DCIST range comprises of these solanaceous trap crops. These are potato relatives, and as such, they elicit the same response for PCN. You plant the crops about May, June time. They grow over the summer, during which time the root exudates stimulate the PCN to hatch very much like a potato crop would. The difference is, however, that the PCN, whilst they can invade the roots through a variety of biological mechanisms and the period of time that that trap crop is in the ground, are unable to complete their life cycle. So reducing the amount of PCN burden on that land for following potato crops, wherever they may be. However, the big problem is, whilst we've had these products available for 10 or 15 years now on the market, farmers have seen varying successes in how to get the most out of these crops. They've seen patchy establishment, sometimes very poor establishment, primarily because these species are not necessarily European, they're more tropical species. And so what the project really wanted to do was to develop that agronomic best practice. How can we as an industry get the best out of them? And we've examined a variety of agronomic factors there, alongside some newer trap crops coming through to the market. So as I say, we've done 2 years worth of field trials now, and we've also put it in the hands of a consortium of growers to see their experiences, fit it into their systems. What we've found is that drilling methods, generally a combi drill seems pretty good, but the key here is moisture. The DCIS seed is very small, it's like a tomato seed or like a sesame seed, and so ensuring good moisture establishment in May or June, which can be sometimes challenging, with a little bit of consolidation if helpful. We've also been able to look at pre-emergence herbicides, so pending registration in the future, these might prove useful. These trap crops, like I say, being sort of exotic, they can be a bit slow to get going unless we get the heat, and so this will really help us in establish more cleaner, better crops in the future. We've also shown the importance of nutrition, so whether that be residual nutrition from previous crops or something that is applied in crop to try and bolster that biomass. With these trap crops, it's really important to get the biomass because big above ground biomass means more roots, means more exudates, more PCN stimulated. But in order to get those optimum rates, there might be a need to apply some nutrition, a little bit of nitrogen or a little bit of phosphorus, for example. We've also been doing glasshouse efficacy, and my colleague from Hartrands has just walked in the room now. We've been looking at a new type of solanaceous trap called DCIS podium, and also benchmarking the existing DCIS trap crops. We found that you can get about 75% efficacy or reduction under optimum conditions, and these newer types of crops, these new species of trap crops, might offer other benefits like frost hardiness or a better rotational position. That's another challenge, is trying to fit it in May, June, when you've still got crops in the ground, or even sacrificing a crop to have it in place. And then, as part of that, we've also tried to put this knowledge on 3 demonstration events where we've had some really good discussions with a variety of stakeholders. And it's been really interesting to see the challenges that they've experienced already, the kind of risks that they perceive. But in general, I would think it's been quite positive to see the progression that we've made, and actually that there might be something useful in the future to try and tackle PCN as a more stacking solution with other varieties of methods, whether that be resistance, tolerance, rotation, or equally synthetic products. The second project I'd like to talk about is much larger, and this is much earlier on. This is Potato Light, a large consortium of across the supply chain, as you can see, and we've just completed our first year of field trials as part of this 4-year project. Really here it's about the cultivation side, so I think this picture really epitomises what is probably typical on many potato farms. We're seeing a high degree of machinery usage to try and get that good seed bed, so that good deep seed bed. But with that comes problems. You know, we're moving a lot of soil, we're disrupting soil structure, soil health. So particularly in a regenerative world, are we actually destroying 5 years of minimum tillage in an arable rotation, or actually are these soils able to bounce back very quickly once they leave? So what the project really is aiming at doing is to develop new types of equipment that can be much gentler on the soil. We are also looking at more minimum style approaches, so 1 single passes or reduced passes, reduced depth of cultivation, just to try and reduce the amount of soil that we're moving, the intensity at which we're doing that, and hopefully also the kind of effect on the soil in general. This is really summarised by these are the project aims. So a lot of it is about trying to move forward in a better way to tackle soil structure and health. We're also going to benchmark where we're at as an industry, so we've got Harper Adams and Cranfield University helping us benchmark what are the greenhouse gas emissions. Are there differences in carbon footprints between conventional tillage or certain types of tillage practices? compared to single pass or more minimum type approaches. How does this affect soil health? Very difficult to define, but we've been using some key metrics to benchmark and to examine going forward. Finally, how can we deliver practical solutions for growers? We're not wanting to create this in a vacuum, so constantly engaging with the growers as part of the project, but we're also looking to engage with the wider industry. And if anybody's going to cup grow, we'll have a workshop at that event where we'll be doing just that, to workshop about the project and to get sort of thoughts and perceptions about that. So I'd recommend coming and attending that. And then finally, looking at how we can improve systems for the future. We're seeing more retailer, more consumer pressure coming through. So actually, can we develop more sustainable solutions that can be put on labels or can be communicated better to consumers in terms of carbon footprint, effects on soil structure and biodiversity. So like I say, we've just completed the first year of field trials. These are not the field trials, but they're representative of the large-scale plots that we're doing in the field. These are not small plot works. These are something at a much more grower scale using grower-sized equipment. We have a variety of sites across the UK from McCain and Pepsi's growers, and we've loosely tried to split these into regen and non-regen growers as well to look at how more regenerative approach, cover cropping, minimum tillage impacts on the types of cultivation regimes that we're looking to instigate, alongside more traditional plough-based and sort of traditional agricultural systems. And these this year form the baseline, and we'll be continuing to do this over subsequent years to develop the project going forwards. The final project I'd really like to talk about is probably quite out there, to be honest. It's very early on in the pipeline, and it's working with a company called Back to Bio, who are originally from a pharmaceutical discovery type background. And really, we've been working with them to help them understand the sector and understand the need for new types of synthetic pesticides or active ingredients, alongside the potential for biological as well. So really, this project comes from that decreasing availability of synthetics and certain active ingredients, and the ability for bacteria in particular to be a really rich source of novel compounds, chemicals. Traditionally, we use things like penicillin and other sort of antibiotics, which are often derived from soil-borne bacteria. But the big problem is that we're only actually able to grow 1% of all bacteria from the soil in the lab. There is 99% out there that's completely untapped, new to science almost, that needs to be unlocked. And Back to Bio have developed a biotechnology way to enable that to happen. So working with them, we've been collecting soil samples and plant samples from potato crops with and without potato blight, and then isolating certain types of bacteria that might be recruited by the plant or might be exposed to potato blight and be useful in tackling it. We've done high throughput screening, primarily from an actives point of view, so looking for microbial compounds. But there is also something in the future that maybe these bacteria could be used in more of a biological way to be applied as bacteria rather than as a discovery for purified compounds. And then finally, we've been working with Rothamsted Research to test these compounds in planter. So we've been growing potato plants down at Rothamsted and infect them with potato blight and also applying these compounds. And we've got some really good results to date. And this is the webinar that my colleague Rosie told you about. So we'll be doing a webinar on this project in full later on this month or December, and we'll have a QR code up at the front if you want to come and sort of register for that and if you have an interest. So some way off yet, but we also have some additional projects with Back to Bio to continue developing this pipeline and bring it much closer to market in the future. So looking to the future, really, I wanted to talk about agri-tech and some of the opportunities that I see it brings. Agri-tech can often be seen as a shiny, techie thing, like robotics and sensors, and it is that, but I think it's also a useful tool that can be used much more holistically. So actually, the sensors, the data, the artificial intelligence, the robotics, the machinery development can all feed into a much bigger, more holistic picture of what agriculture and farming looks like today. Can we use this, like I've shown, to discover more biological-driven ways, either through prospecting for microbes in the soil or through making better decisions through accessing data using biologicals in a more targeted manner when conditions are good, making the more economic use of them? Can we redefine our farming systems across rotations to take that much more longer view of what is happening in a field? Very difficult in potatoes, I appreciate, but this is something that we're beginning to see a lot more of. Are there new crop and diversification opportunities? So with the advent of either traditional breeding or gene editing, does this open up new opportunities for us as a sector? Or equally, can we use technology to grow crops that we traditionally couldn't grow very well? So for example, we're seeing a lot more interest in protein crops for beans, pulses. Can we use technology to help us improve the way in which we farm them and the efficiency with which we can do that? And then finally, can we also use it for much more environmental purposes? Can we use technology, imaging, data, a variety of tools to really map farms in a much more granular way? We can get down to roughly square metre footage on satellites now. Can that help us identify where best to put environmental schemes, to plant woodland, to put in leaky dams into ditches, rather than having to walk and think about it? Although the two go in hand, don't get me wrong. So I think it really offers us lots of opportunities as a sector going forward. So there's just some thoughts that I'll leave you with. If you have any questions about the projects today, feel free to come and talk to us. Myself and my colleagues, we're on stand 139. You can also follow CHAP, and we have some of these projects up on our website as well. And you can always get in touch. There's no email address, but we do have an email address if you want to get in touch. But that's it from me. Thank you very much.
Thanks, Alex. And there is also a leaflet on the DCIS project, and the email is on here as well. So thanks very much. And I think it just goes to show that with agri-tech, maybe we tend to think of robotics and drones and things, but I think Alex has shown that actually there's some very novel approaches that we really have to address. I mean, some of these are closer to market than others. I think the DCIS project is a really interesting one, and actually Alex has brought some plants over. We have some trap crop plants for you to have a look at if you want on our stand, which is 139. I think the potato light is really fascinating. It's going to be a difficult challenge, I think, for potato production to go fully into regen ag, but I think there will be some very interesting outcomes from that. And again, I think the biological control of crop diseases, again, is a very interesting topic. And that sort of leads on to our last speaker, which is Dr. Faye Ritchie, who's the Technical Director at ADAS. And she's done a lot of work historically on potato late blight, and she's going to talk about managing fungicide resistance in the potato crop. Thanks very much.
Thanks, Rosie. Yes, good morning, everyone. It is still the morning. So yes, yeah, that's fine. Yeah, so I thought we'd talk today about fungicide resistance management strategies and do they work for late blight? I mean, these were questions that were coming up several years ago when we had 37A2, which is the strain that has got insensitivity to fluazanam, appeared on the scene. And actually there was very little evidence from the field that showed us whether these worked or not. And of course, the first point of call when it comes to resistance management and guidelines would be the FRAG UK guidelines. They outline non-chemical control options and also things related to chemical control. Non-chemical control is often overlooked, but if we don't get an epidemic, then we don't have any strains and we don't have any selection for resistance. So non-chemical control measures are actually a really important part of resistance management. When it comes to chemical control, we've got to think about two things. We think about the effectiveness of a fungicide programme, and that's really balanced with resistance management as well. So we're thinking about tight spray intervals, optimising applications, but for resistance management, what we're looking at is making full use of different modes of action. And also, there's always the question about alternation or mixtures. Which approach should we use? Which one is best? And several years ago, we didn't actually have an answer to that question for late blight in particular. So what is the evidence around selection, and what are the things that drive selection for fungicide resistance in general and fungal pathogens? Well, this is a review that was done about nearly 10 years ago now, which looked at a range of studies that were related to testing fungicide resistance management strategies. So all the numbers you see there are studies, numbers of studies. So if we look at increased dose, what they found when they looked across 19 of those studies, that in 16 of them, they increased selection. So where you're using higher doses of fungicides, you're increasing the selection, which is the opposite of what we've always kind of considered to be the case. If you increase the spray number, again, there were 6 studies that looked at that, and all of those increased selection. So putting on more sprays will increase selection. The 2 sort of standout things from this review were the effects of adding a mixture partner in your sprays and also alternating sprays. So when I say alternating, that means applying, say, product A, followed by product B, followed by A, followed by product B. So adding a mixture partner, the majority of those studies decreased the selection for fungicide-resistant strains, and same for alternation. They also looked at adjusting the timing, so applying something maybe 7 days, 10 days, but there wasn't really enough evidence for yes or no for that one. So mixture partners and alternation are clearly really important. But the question is, how do they work for the control of late blight? And we looked at this in a 3-year project, which started in 2019 and ran till 2021. So the report was published last year. And it was an industry initiative. It brought together 5 of the agrochemical companies, 2 distributors, AHDB, and from a research delivery point of view, ADAS, James Hutton Institute, and SRUC. And we set up a series of experiments to look at this. So what did we want to do? Well, we wanted to see whether we could identify practical and effective resistance management strategies when controlling late blight. So we only wanted to look at practical strategies, and we also wanted, once we'd done that, to incorporate these evidence-based findings into guidelines, and those would help to outline best practice for the industry. So what did we need to know for late blight? Well, a lot of the studies that have been done before have looked at crops that receive 1 or 2 fungicide applications. We know that blight can receive, potato crops can receive 12, 15 in a season. So we needed to know what would happen over a longer period of time. We needed evidence to see what actually happens if a mode of action is applied repeatedly, and what happens if we're applying a fungicide with no reported insensitivity. And does fungicide dose actually increase or decrease selection when we're thinking about potato blight? And then we looked a little bit more at the exact fungicide programs. So we looked at alternation, how effective is that, and does the order of those applications matter? Blocking applications is often cited as a reason for resistance occurring, but can we actually see that in our experimental trials? How effective are fungicide mixtures, and also should we be using single-site or multi-site fungicides? So those were the questions that these trials were set up to answer. So what we did was we used 37A2. So this is the strain that's in the population that has insensitivity to fluazanam. And it was an ideal candidate for including in these trials because it is in the current GB population and it was present at a low frequency. So we can design experimental treatments in order to artificially select from it and test these strategies. So we're using it here as an experimental model to represent how strains might be selected for in general. So don't think of this as fluazanam and other, just think about it as what happens if we put on a mode of action continuously? What happens if we use mixtures? What happens if we use alternation? Just to say that these experiments didn't test season-long disease control, and they were designed to test selection only. So the information shouldn't be used to justify similar mixtures in the field. But the principles can be used to put together fungicide programs, and also if you're trying to design test programs for testing experimentally. So these were the different treatments. I just want to take a little bit of time to explain those to you so we can interpret the results. So we did this as a fungicide program. So there were 6 sprays in total. So we start at the left, and at the top we applied fluazanam only. So that represents no resistance management strategies at all for that mode of action through the fungicide program. And at the end of the row, you'll see it says total units of fluazanam is 6. So what that's telling us is we put on 6 full doses of fluazanam as part of that fungicide program. Below that, you can see we had a single-site mixture and a multi-site mixture. Again, these were season-long. the same amount of fluazanam applied, but the only difference there was we included a mixture partner. And then we had the alternation, 2 alternation treatments. We also had the blocking treatments, and we included in a half-dose mixture as well. Now, all of those treatments received exactly the same amount of fluazanam as part of their treatments. And then at the bottom, we've got the multi-site only, which received no fluazanam at all. So that's really representing what happens if we're applying fungicides to a population where the entire population is sensitive to that mode of action. So how did we do that? Well, we took lesions from the trial area before the fungicide programme started, and these were genotyped by the James Hutton Institute. We then applied those 6 fungicide applications, so it's a 42-day programme. The lesions were then taken from individual plots, and we were able to calculate the proportion of 37A2 left in the plots after the fungicide applications, and gave us a way of determining how the different strategies affected selection. So what did we find? On the left-hand side, you can see it says the selection coefficient. It's just a fancy way of saying the sort of ratio between 37A2 and all the other strains that were present in the population. So you can see that where we put fluazanam on season long, so again, this is representing just putting a fungicide on season long with no resistance management in there, that your selection was significantly higher than where you did use resistance management strategies. If you move along to see the single site and the multi-site mixtures, you can see that they statistically significantly reduced the selection for fungicide-resistant strains. So we put on the same amount of fungicide, the same amount of the at-risk fungicide in this case, but just including that mixture partner substantially reduced the selection for that strain. If we look at the alternation treatments and the blocking treatments and also the half-dose, in these treatments you're putting on exactly the same amount of fungicide, and we actually couldn't pick up a difference between them at all. And right on the end, you've got the multi-site fungicide where you're getting barely any selection for that strain at all. So we can simplify that just by combining some of these treatments together. So season-long application of a single site mode of action substantially increases the selection for resistance. However, all those resistance management strategies were very effective, with the lowest amount of selection where you were using a completely different mode of action. So I just wanted to look at this chart. So these are the modes of action that are currently used on potato. This is information from the DEFRA pest and disease, the DEFRA pesticide evaluation reports, and the differences between 2018 and 2020. And what you can see is that there's been a small shift in the range of modes of action that we generally use across the fungicide programme, but there still is quite a reliance on mancozeb and cymoxanil and cyazofamid. So it's worth thinking how resistance management strategies fit into your fungicide programme. So what were the conclusions from that? Well, good disease control is a balance between the effectiveness of a fungicide programme and resistance management. All the resistance management strategies that are recommended and were tested here decrease selection. So alternating and using mixtures are both important and effective resistance management strategies. Of course, there are other things to consider when thinking about alternation. If there is a strain that's present in the population that you don't know about and you're using an alternation strategy, you might have a gap in the programme. But that's just something to think about. So the repeated and sequential application of a single site mode of action will result in the selection for fungicide and sensitivity. So resistance management is very important. And although it's probably not adding brand new information, I think it really supports the recommendations that we've already got out there that are in the FRAG guidelines. So I think they're an important part of the resistance management decisions. Cultural control is really important for resistance management as well. If we don't have an epidemic, we won't have selection. And using that range of fungicides from different modes of action and using alternation and mixture strategies is important across the board. And to avoid overuse of single site modes of action in the programme. and multi-sites, the risk of resistance development is very low. So continuing to use those is also an important part of the programme. And just to say thank you to everybody who was involved in the project and the funders. Many people have maybe moved on or changed roles, but just to acknowledge them and the funding we got from the organisations.